Okay, so let's get started. This is me. I am Manuel Romero. I am a senior global enterprise architect at Qlik, member of the GEAR team, the Global Enablement and Architecture and Research team. Before that, I was a tech lead in Qlik R&D, and it's now 4 years and a half so far. Very happy working at Qlik. So the agenda for today's presentation, so I'm going to be giving some landscape background, orientation about Qlik and big data. I'm going to go through the different use cases we can use QABDI today based on the ODAG approach or just using QABDI for data extraction. I'm going to be showing as well some architecture, high-level architecture of QABDI, and then how it can be deployed and what's the actual configuration to get QABDI up and running. And I will finish with some demos, get our hands very dirty, showing the real stuff about QABDI. Okay, let's start. Landscape. So with this slide, so what I want to talk about is what are our observations in Qlik of how traditional data lakes have been used so far. So they are basically IT driven. So initially there was a need to store data coming from different data sources, whether the data can be structured data or unstructured data. IT was enabling these data lakes to get that data in it. But the thing is that there is no purpose, no proper analytics requirement. So the data was there in the data lake, but there was no idea of how to actually exploit that data and get some insights out of it. So what we believe in Qlik is that traditionally what we've done is getting that data out of the data lake and get that data closer to the analytics tool. Using, for example, Impala or Spark, MapReduce, and all those of execution engines on top of a big data lake. But our approach here in Qlik and with QABDI is, instead of getting the data closer to the analytics tool, what we want to get is the data, the analytics tool closer to the data, bring the analysis closer to the data lake. So that creates a governed performance layer, which is optimized for analytic use cases, and you will see that in a moment with QABDI. And you can perform very fast queries against the data lake because you're not moving the data. The data still resides and lives in the data lake. There is no actual data going back and forth from the data lake into the analytics tool for it to be analyzed. Okay, a little bit of some methodologies we are using in Qlik to deal with big data. You know that there is a bunch of it. We can simply use the traditional in-memory apps, some segmentation or chaining, as we've been doing with QVDs in Qlik View, but also we've got now on-demand app generation. So we are not saying the rest of the presentation is going to be focused on on-demand app generation, and we are not saying that this is the one solution to fit all the problem. So this is one option, and depending on the use case of your customer needs to solve, you can go to either one or the other, a combination of some of them. All right, so let's focus now on the use cases of QABDI. This is a high review of the different use cases for QABDI. So on the left, you've got the data lake, right, where your raw data, structured and unstructured data is stored. And now what you want to do is perform some analysis of that data. Right, so first, for QABDI, you need to create a star schema for indexing. right? So, and in order to create that star schema, potentially you can use, one of our new products in our portfolio, which is Qlik Data Catalyst, that helps create that star schema for preparing, getting that star schema in our in the actual Qlik Associative Big Data Index layer. Here you can see that the big data, the QABDI layer runs with Docker and Kubernetes as the orchestration layer, and it's got two parts. One of them, it's dealing with that star schema and creates an index of the data, and then it exposed a model that it can be consumed by a Qlik Sense client in three different modes. You can either go for a live mode, where you are accessing directly the QABDI index without no need to load any data into memory. So directly from the UI, you would interact on top of the index directly of the data lake. There is another approach, which is the ODAG mode, that you would use the ODAG approach and paradigm to extract just that slice of data into an in-memory app that ultimately you can apply some logic and UI on top and perform your analysis. But also using the script mode, which is the last use case, you can just extract using the QABDI connector, a new connector you can now use with QABDI, to just extract very easily from the QABDI layer that portion or a slice of data you want to load into memory and perform the analysis upon. On-demand app generation and QABDI. So this is just a reminder of how on-demand app generation works. So you know that you've got a selection app, that it's a high overview, aggregated view of all the data living in the big data repository. And in here, you can perform some selections, and given those selections, these are passed through to an analyze detail app that just loads that portion of data. So QABDI and ODAG works very nicely together. That's because you can use QABDI to extract that slice of data very, very easily without moving any data from the data lake right away on top of the index, accessing right away the QABDI index, instead of going through some, Impala jobs or Hive queries, ODBC connector, which ultimately are running Spark jobs, or Impala queries, or which usually takes a lot of time to get and extract that data into your in-memory app and then perform the analysis. Okay, so the first couple of use cases are about ODAG, on-demand app generation. So traditionally, you've got both the selection app and the detail app, getting the data loaded into memory through an ODBC connector using Impala, Spark, Apache Drill, MapReduce, all those of big data technologies, Hadoop technologies. And then the detail app as well, using that ODBC connector, extract the data, performing some selections, and load, select the statement, and get that data into the app. What we are proposing here with QABDI is modifying you could keep the selection app as it is using ODBC, but now the detail app can request directly the QABDI index closer where the big data resides, and extract that slice of data in a very easy and quick way. Use case 2 would be having both the selection app and the detail app accessing directly the QABDI index. This is what we called live mode. And then the last use case, it's about just data extraction using the QABDI connector, where you can perform a selection right away on top of the QABDI connector and accessing the QABDI index layer very quickly without the need of loading any additional data into memory, and using some QSL statements scripting very quickly that will get injected into your load script editor. We will see that later to demonstrate how this can be used. Then about the architecture. All right, so as we've said, QABDI is running usually in, at this point in time, we support AWS, Amazon, and you've got your data lake, which could be a Hadoop cluster, and then you would generate your star schema based on the data living in your Hadoop cluster. And then the QABDI layer engine is running using Docker containers and Kubernetes as the orchestration, the Docker orchestration mechanism. Here you can see some different containers or servers, as we can call it. Some of them are dealing just with the indexing part, that's the indexing cluster, and some others are just dealing with requests coming from the Qlik client using QSL syntax and queries. And you will have some containers dealing with the hypercube calculations, the associative experience. All the magic is happening within this QABDI layer. Deployment and configuration. Okay, in order to install and get QABDI up and running, so first we need to have our Kubernetes cluster in Amazon up and running, and then have deployed all those containers within our Kubernetes cluster. Right, so the initial Docker images, meaning all the software that has to be installed in our Kubernetes cluster, it's usually in JFrog bin tray. Here we've got charts, which is just a definition of how the different Docker images has to be deployed in our Kubernetes cluster. And to do that, we use Helm. Helm is just basically a package manager for Kubernetes. And just very simple command line, you would get deployed an instance of those Docker images as pod, as they are called in Kubernetes, deployed into your Kubernetes cluster and having QABDI up and running. Then, first, we need to create and prepare the data. At this point in time, QABDI only supports Parquet files. Parquet files is just a columnar representation of the data, of the raw data living in your Hadoop cluster or wherever in your data lake. But it needs to follow this structure. So first, a first folder with the name of the data set, of the data model you want to explode the data upon. Then some subfolders about the different tables with that specific naming, first.table, payment type.table, and then within that another subfolder called first.parquet for the first table, and then within that all the Parquet files with the actual raw data. That's the definition of how the data needs to be prepared for the QABDI index to be able to create the index. Then you have to start your indexing services, and for that at this point in time, it's through some scripts that you run within the Bastion container, which deals with the management and configuration of the QABDI index. Then you would start the indexing services and then start the actual indexing process, running those scripts. Eventually you will have some screens with data as shown on the images on the right. Of course, you have to also run the services enabling the QSL access. Same way, there is another script to run those scripts and enable the outside access to the QABDI layer to perform some QSL queries and select data from the QABDI index. A new thing, Qlik Selection Language, QSL. So this is a unique new language optimized for the Qlik Associative model for QABDI. And you could, for example, have just a live mode which only loads metadata, and it's as easy as just connect using the QABDI connector, and then just type import live and the name of the model. And of course, you can also perform some data extraction, again connecting to the through the QABDI connector, and apply some load QSL select statements instead. This is the way. There is a new syntax. It's very similar to set analysis, and to basically perform that data extraction from QABDI. For example, when we are dealing with ODAG paradigm. And at the very end, you basically create a load QSL select and apply a selection state to that load statement. You will see that with the demo. Okay, time for the demo. It's time to get our hands dirty. Let's go ahead. Okay, let's exit the presentation mode and into the actual demo. First of all, I'm going to show you how the QABDI index is running behind the covers within the Amazon AWS Kubernetes cluster. So here in this terminal window, I'm logged in to the AWS Kubernetes cluster where I've got QABDI running. First, we can, for example, list the different containers running within my Kubernetes cluster. And here we can see that we've got multiple QABDI containers. For example, the Bastion, which is used for management and configuration of the QABDI layer. Some containers performing the index. Some containers dealing with the QSL queries coming from the Qlik client, and on and on. So, for example, what we can do here is enter the Bastion container. So for that, I will execute this kubectl command in order to open a shell into the Bastion container. Now I'm within the Bastion container right here. And for example, we can see that here we've got the data that we are going to create the QABDI index upon. This is about New York City taxi rides. All information about rides in the city of New York City, you know, fares, pickup date time, drop off, total amount, payment type, and all that information related to rides, you know, taxi rides. Here in the output folder, we've got the actual index already being created because I've run the creation of the index already up here. So the index is already created, and I've run those scripts that I showed you during the presentation in order to get the index created and up and running. But also what I wanted to show you here, it's this configuration information here. It's within the runtime folder, then config. And here we've got the configuration we need to set up within the QABDI index in order to create the index of the actual data. So for example, let me show you the indexing setting JSON file. Here we are specifying some information about, okay, where the output folder would be. In this case, it's home output. What's the name of our model, the QABDI model exposed for our QABDI layer, where the data, the Parquet files is located, you know, what's the field mappings file .json that I will show you just in a moment. You know, some initial configuration for our QABDI engine to know where to get the data from and how to create the index upon. Let me show you the data, the field mappings file. And here, with this configuration file, we are specifying the associations between the different tables, the different Parquet files for our data. In this case, it's our New York City taxi rides dataset. And here we are specifying the different associations for the different fields, so the QABDI index knows how to perform the associations later on when it calculates the hypercubes and the associative experiences happening in the QABDI layer. Alright, what we can do as well is go here inside the scripting, the indexer folder, and here we've got the scripts to start our indexing services. I've already done that, but we can see what's the status of the creation of the index so far. So previously I've gone through all these steps in order to start the creation of the index. But with the option L, I can list what's the status of the creation of the index. And we can see that already we've created the symbol table, we've created the column index, it's as well 100%, it's completed, and the association for that index, it's also 100%, so it's completed. So we can say that the index is created, and actually we can go here into our output folder and see that, hey, we've got here a bunch of folders where our index is living, and the QABDI engine gets access to this index in order to perform all the magic, right? So our QABDI index is up and running, and it's ready to use. It's just a matter of accessing the engine, performing some QSL select statement. All right, so now we can continue with our demonstration. Let's jump now into Qlik Sense to demonstrate the 3 use cases or modes we can today use QABDI for. But first, let's talk a little bit about the scenario itself. So these are 2 pre-built applications dealing with data about taxi rides in New York City. These applications are following the ODAG paradigm, and both load the data using a traditional ODBC connector to access the data in the Hadoop cluster, in the big data repository. One of them is acting as the aggregated view of the data, and in it we can make selections to select the portion of data that will be loaded into the second application, the detail app, where the final analysis is taking place. As I said, this detail app also uses ODBC to load the data, but it also applies a where clause to filter that portion of data indicated by the selections being made in the selection app. So, having said that, and in order to demonstrate the QABDI mode, all we have to do is modify the ODAG scripting of the detail app so it accesses the QABDI layer instead to load the portion of data right away from the QABDI index. Let's go ahead and open the detail app, enter the load editor, and start our scripting modifications here. So let's start our modifications of the ODAG section. Here we've got a typical ODAG scripting that it's used to create the where clause that will be applied to the final fact table when we load the fact table using a load select statement. So the first modification we have to do is to one of these subroutines. Instead of creating a where clause, as we are now using QABDI, what we are doing is creating a selection state. So we rename this subroutine here. Then the variable where part, where we were appending the different where parts for the different fields that we are binding from the selection app, we are now creating a selection state variable. So we rename that variable all along in our script down below here as well. So here we were appending the selection state with the different where part you would use in a usual SQL statement using an ODBC connector. But now here, what we have to use is QSL syntax instead, given that we are now dealing with a QABDI application. So I've got here the syntax for the QSL statement. You have to believe me that this is the way you would do it using QSL. I'm not going to go into the detail of the QSL syntax, but basically what we are doing here is creating a dynamic selection state using QSL syntax, given some bindings for different fields that we are passing from the selection app to the detail app. There's no need to make any modifications for this subroutine. And down below here, what we've got is the ODAG binding, the fields that we are passing from the selection app to the detail app. In this case, we are binding the rate code, payment type, and pickup date time fields. A modification we have to do here is say that instead of using a single quote character in order to create that dynamic where clause, as we are now creating a selection state and using QSL syntax, there is no need for that single quote character, and we need to pass a null value, which is specified by this 0 value for our build value list subroutine. Then, instead of using an ODBC connector, we have to use a QABDI connection instead. I just created a QABDI connection instead, but you can of course create your own. Go into the creation panel, select QABDI, and specify some values for where your QABDI layer is running. Here, for example, this is the URL where our QABDI layer is running in Amazon, in AWS. This is the default port. Our data model is called New York City Small, and of course we give it a name. Let's test it. It's okay. It's all good and running. So we can use it here. Now for the different fields we are binding, we need to create our dynamic selection state calling the modified subroutine. Then we load our fact table, our actual data. First, we need to create a QSL set handler for the past selection state. We are dynamically creating, right? And we have to specify this is not a load select traditional statement. Instead, it's a QSL select, and we specify that like that, just saying this is a QSL select. And finally, we load the data from our model, which is called New York City Small, and the fact table is called first. And we apply our selection state, given the QSL handler for our selection state. And if I haven't done any mistake, we are good to go. We are done with the modifications of our ODAG scripting in order to access our QABDI layer and load the data directly from the QABDI index. So now we can jump into our selection app, our aggregated view for our data in our big data repository, and create an ODAG link to create our detail app. So we create an ODAG link. For example, we can call it ODAG extraction data slice. Our template app, it's the detail app. We just modified the ODAG scripting. Let's limit the ODAG creation by saying that the number of offers should be less than 10,000, and Well, let's keep that ODAG application up to 1 hour. That's the retention time. And then we open the detailed records sheet right away. We've created our ODAG link. We drag and drop that to our navigation panel. And now we can start making selections here in our selection app. Let's filter just those values given the rate code field equals 6. You can see here down below that the ODAG link now is activated, and we can run our ODAG application, accessing the QABDI index right away. So we generate our ODAG application. Let's have a look at the log progress. Now we are done, and the ODAG application is created, and indeed it just loaded 79 first. And here is where we can perform our final analysis, because here we've got the low-level row details of the data. We can of course change our selections here. Let's focus now on rate code 6 and 4. Still our ODAG link is active as the number of firsts is less than 10,000, and we can either generate a new app or just reload our recently created app using the current selections. We can have the progress, have a look at the progress. Yeah, we've loaded just the data. Go here, refresh, and verify that indeed just that portion of data is loaded in memory into our detail app. So we are now done with the first use case, the ODAG mode, where we've modified an ODAG detail application, the ODAG scripting of it, so it accesses the QABDI index right away in order to load that portion of data into memory. So now what we can do, and this would be the live mode of QABDI, is creating a selection app based on a live mode. So let's go ahead and do that. Let's jump to the hub and create a new empty application. Let's call it live New York City mode. We open the application and access the load script editor, and in order to access the QABDI index right away in the live, using the live mode, we just use the QABDI connection here, and with this simple line of code saying that we want to import live and the name of the model, we are pretty much done. But we need to set also this value to 0 because currently QABDI doesn't support the creation of the index at reload time. But we are done. So we load the data now and see how fast that loaded. Because this is just loading metadata, it's not loading any actual data into the app. We open the app overview, create an empty sheet, and let's inspect the fields. And here we've got all the fields directly from the big data index. We can drag and drop the fields here on the sheet. For example, the rate code name, payment type, I don't know, drop off date time, something like that. So every time we perform a selection here, and the calculation of the associations and the associative experience is not happening in Qlik Sense anymore in this live mode. Everything is happening in the QABDI layer instead. So we can change our selection here, and every time we perform a selection, all the calculation of the associative experience and the associations are happening in the QABDI index. And that's because behind the cover, QSL queries are triggered from the Qlik Sense client to the QABDI index, and then getting in return the associative experience here on the UI using list boxes. In the live mode, as we've said, we can only use list boxes for now. Not all the features of Qlik Sense are supported in the live mode, but what we can do is use our live mode application, accessing the QABDI index directly, in order to create a link, an ODAG link, which is the live extract QABDI, for example, QABDI. Use our modified detail application that is already accessing QABDI layer by the ODAG scripting. Limit the ODAG creation by the count of drop-off at the time field, for example. That count should be less than 10,000. The ODAG application retention time to 1 hour, and it will open the detail records sheet right away when it opens. And run this drop off the time, and now we create the ODAG link. We drag and drop that on the navigation panel, and we can perform a selection using the live application as our selection app. Let's, for example, select rate code 6, and if we remember, that generates an in-memory detail app of 79 records. So let's generate that ODAG application, in-memory application. So the in-memory ODAG application is now created, and if we open the application, yes, here we got the 79 first, loaded into our in-memory app where we can perform the further analysis. Let's now demonstrate the script mode for QABDI to extract the data from our QABDI index into an in-memory app. So for that, we can go to the app and duplicate the template app of the detail application. So we make a duplicate of it. We open it. We enter the data load editor. We can still see the ODAG section here we had before, but now we are not using the ODAG mode anymore. What we are gonna do is perform a QABDI extract. So we can entirely remove this script here and use the QABDI connector, open the dialog, and select from our QABDI index what portion of data we want to load into memory, and extract that data and load it into memory. We insert the script. This of course generates the script for us with some QSL select statements here, some loads statements, filtering the data given the rate code equals 6 as we've specified using the QABDI connector. We load the data. It's loading 79 lines, rows of data, and if we open the app, there we go. We verified that indeed it just loaded that portion of data where we can perform our further analysis right away. So we've just extracted from our QABDI index using the script mode and the QABDI connection and some data to load it into memory. And we are done with the demonstration of the different use cases you can use QABDI for today at this moment in time. Alright, so demo time has concluded, and now it's time for some question and answers.
All right, everyone, now it's time to enter your questions in the Q&A panel on the left side of your console. Go ahead and take a look, Manuel, and see which ones you want to address.
Alright, so we've got here a few questions. Okay, let's start with this one. Question says, will it work with MapReduce? How much load does it put on the MapReduce cluster? So the thing is that QABDI has nothing to do with the traditional big data technologies. This is a totally different approach. We are not using any traditional Hadoop big data technologies as MapReduce, Spark, Impala, and instead we are replacing them using QABDI. We are putting our QABDI index close to the data lake where the big data lives, and we are getting access to that big data index directly from the client, from Qlik Sense. So to your question, will it work with MapReduce? It has nothing to do with those kind of big data technologies. It's a totally different approach. Okay, another question, will it be available for little organizations and cost, financially costing? So the answer is yes, this is available for all type of and size of customers out there. And there is at the moment an open alpha program where you can enroll. So please contact your customer success person in Qlik or your pre-sales guy and get that information directly from the product management team here in Qlik, because I don't have it right away. But I know it's available for all type of organizations and customers. Please just ask for it. Another one, does QABDI use or take big data with a special platform? Is there any connector to use? Well, yes. Now here with the demo, I've shown you that there is a new connector called QABDI to connect to the QABDI layer, which is living in Amazon AWS or wherever you have it deployed. And with that connector, you just can create some index and extract the portion of data you want to perform your analysis upon. How much of a current architecture is impacted if one is fully deployed already currently? Okay, say that for example you've got a Qlik Sense server on-premise, either deployed on-premise or in the cloud. So in order to add QABDI into your architecture, as we've seen, this is all running in the cloud. At this point in time, only we support Amazon AWS, and you need to have a Kubernetes cluster running in Amazon. The preferred option is in EKS, which is the Elastic Service Container for Kubernetes in AWS. And that's the sort of architecture and hardware that you need to add to your current architecture. And so yeah, that's it. So you have to have a Kubernetes cluster running in AWS in the cloud, and deploy the QABDI software in it, and get the creation of the star schema and perform the creation of the index based on the data living in your Hadoop cluster. Question, is this QABDI ready to run in the cloud? Oh yes, it is. So traditionally a Hadoop cluster, data lake, usually is deployed in the cloud traditionally, and then the same way QABDI, as we want it as closer as possible to the Hadoop cluster where the big data is stored, as well it runs in the cloud. So yes, all runs in the cloud at this point in time, AWS and Amazon. Question, how does QABDI keep itself synchronized with a data lake, which is regularly changing artifacts or different schemas? So the thing is that when you've got some data to analyze living in the data lake, you create this start schema and these Parquet files in order to create the index upon. And then once the index is already created, that's something that you perform only once. Whenever there is new data coming in or anything changes in the schema, the index containers, the containers performing the index and creating the index, will take care of any change that is happening in the backend, in the data lake. And it will create the index automatically, almost instantly, and that ultimately will be available in the UI, in the Qlik Sense client, almost in real time.
Manuel, we only have time for one more question.
Okay, thank you. The last one, how does it integrate system architecture-wise with View, Sense, and Data Catalyst? Oh, nice you mentioned Data Catalyst here. So QABDI is a separate product, so you deploy it aside your current Qlik Sense installation. And then View, I'm not sure if you can use View with QABDI. What I've seen so far is only Sense accessing the QABDI index. But one important thing here is that with Qlik Data Catalyst, this new product, is a very good way to create that star schema and prepare your data source in the data lake for it to be used by the QADBI index. So yes, all these products tie together very nicely, and Qlik Data Catalyst will be integrated with QABDI in the future. And so the integration hopefully it will be very smooth and seamless. So that's it. Thank you very much.
All right. Thank you, everyone. We hope you enjoyed this session. Thank you to Manuel for presenting. We always appreciate getting experts like Manuel to share with us. Here's our legal disclaimer. And thank you once again. Have a great rest of your day.